Hello students and welcome to IP Study Lecture videos. In this video, we are going to cover the third chapter of grade 8 mathematics and the name of the chapter is Squares and Square Root. Students, first of all, let us see what are the different topics we are going to cover under this chapter. So we'll see what is the meaning of square of a number. Then we'll see how to check if a number is a square or not. Then we'll see how to find the square root of a number. And in the later part of the video, we'll see how to find the square root of a decimal number also. So first of all, let's start with the concept that what is the meaning of square of a number. So student, we have already understood in the previous chapter that what is the meaning of exponent and base. So let's suppose if we have an expression like this, then the whole expression is called power. This number is called the base and this is called the exponent. And it represents that 5 should be multiplied 3 times to find the answer, which will give us 125. Now student, if the exponent on a number is 2, then we say that we are squaring that number. It means if we have 5 raised to the power of 2, we call it as a square of 5 or 5 squared. And it represents that 5 should be multiplied 2 times. 5 times 5 is 25. So square of a number means we have to multiply a number by itself. Yes, so here is a definition. When a number is multiplied by itself, we say that the number has been squared or the product is the square of that number. So this is the number 5 and we multiply it by itself and the result is the square of the number 5. Yes, so here are some examples and how to read these numbers. So we can read this as square of 5 or 5 squared is 25 and so on. Okay, now what is a perfect square or square number? Student, if we write different counting numbers like 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on, we can see there are certain numbers which are square numbers. Yes, like this. These two are square number 1 also. So these numbers which are square of a particular number, that number is called perfect square. Yes, so 1, 4, 9, 16, 25 which is a square of 5, 36 which is a square of 6. So these numbers are called perfect square. Yes. Now next is geometrical interpretation of perfect squares. So we can represent square number using dots where the number of dots will correspond to the square number it representing. Yes. Now how to check a number is a perfect square or not? So for that what we do is we prime factorize the number and we make pair of each factor. If all the numbers are categorized as a pair, then the number can be considered as a perfect square. Now if we prime factorize this number, we'll have 2, then we'll have 50 over here, then 2 again, then 25, then 5 and again 5 over here. Now if we write the prime factorization of 100, it will look like this: 2 times 2 times 5 times 5. Now we can pair these factors which are same and we can also factor these pairs which are same. Now all the factors are present in the form of a pair, so we can call it a perfect square, and if it doesn't, then we call it as a non-perfect square number. Yes. Now numbers between consecutive square numbers. So if we take a square number like square of 6, 36 and the next square number that is square of 7, 49, then the number of non-perfect square, because the numbers between these two numbers that is 36 and 49 will be non-perfect square, and the number of non-perfect square between these two can be finded out by the formula 2n, where n represent the first number that we have taken, that is 6. So 6 is the first number whose square is taken here. So the number of non-perfect square will be 2 times 6, 12. Clear? So this is a formula of finding out the number of non-perfect square between two consecutive square number or perfect square numbers. Yes. Now Here is an example that we have already covered, that how to check a number is a perfect square or not. So the first is, are 7056 is a perfect square or not. For that, what we have done is we prime factorizes the number and then we write the prime factors like this and pair each of them. If all factors get paired, then we say that the number is a perfect square. Yes, so you can go through these two examples and understand how we can check that if a number is a perfect square or not. Clear? Now next is properties of perfect square. So there are certain properties of square numbers which help us to deal with square numbers in an easy way. So what are the different properties? Here are some listed one and I will go through some of them. So student, if you find out the square of numbers from 1 to 10, you will observe that the unit digit of square numbers follow a certain rule, like square of the unit digit of square of 1 is 1, 2 is 4, and 3 is 9, 4 is 6, then for 7 it is 9, and for 8 it is again 4, and then for 9 it will be 1, and for 10 it will be 0. So we can see that there will be only this as a unit digit of a square number. Yes, like there will be no number whose square will have a unit digit 2, 3, 7 or 8. So if any number is given with these unit digit, then we can directly say that that number cannot be a perfect square. For these numbers we have to check, but there are chances that they can be or they cannot be. But it is sure that if a number has these numbers as a unit digit, then that number cannot be a perfect square. Yes, so similarly you can go through some of these properties and understand how to deal with perfect squares in a easier way. Clear? Now I will take one more property, that square of a natural number other than 1 is a multiple of 3 or exceed a multiple of 3 by 1. It means if we take any perfect square and if we divide it by 3, then there are two chances only. Either the number will be divisible by 3 or the remainder will be 1. So this is an interesting property on which you can ask each other questions based on this. Yes. Now next question is finding Pythagoras triplet whose smallest number is 10. How we can do this example? So there is a property, we say a triplet ABC of a 3 natural number ABC is called a Pythagorean triplet if it follows a rule where the square of the 2 has sum which is equals to the square of the third. Yes, so here we have a rule where it says if m is a natural number, then if we find out 2m and m square minus 1 and m square plus 1, then this will be a type of or an example of Pythagorean triplet. So whose smallest number is 10. So what we can do is we can check how we can find out the m using the three cases that we have. So smallest number, it can be using 2m or m square minus 1 or m square plus 1. So we can see that these are not possible, and here we get m as 5. So the m is 5, we can find out other by putting the value of m over these two. So m square, that is 5 square minus 1, that is 24, and then 5 square plus 1 is 26. So this is the method of finding out Pythagoras triplets if we are given with one of them. Yes. Now next question is find the smallest number by which this should be multiplied to make it a perfect square. So student, in this type of question where we are asked to multiply or divide something to make the given number a perfect square, what we do is we prime factorize the number like this and we make pair, and we check what numbers are not present in pairs, and we have to multiply or divide that number only. Yes, so here we can see that 7 is unpaired, so we have to multiply 7. Yes, and the new number after multiplying 7 in the present number will be a perfect square whose the prime factors will be present in the form of a pair. Yes. Now how to find out square of a number using shortcut method? So we know that a plus b whole square is equals to a square plus 2ab plus b square. Now we can use this property or formula to find out the square of a number without multiplying it. Yes, so you can go through this concept. Yes, now moving to the next topic, that is square root. What is square root? So student, we know that a square of a number means we have to multiply that number by itself like this. Now 25 is the square of 5. Yes, similarly we can reverse the concept and we can say 5 is the square root of 25. Yes, so it says if a is equals to b square, it means 25 is equals to 5 square. Here a is 25 and b is 5. So then it can be read as a is the square of b. Yes, this a is the square of b. Yes, here a is the square of b and b is the square root of a. As I have already told you that in reverse process we can say that 5 is the square root of 25. Yes, so here we can understand it that for every perfect square there exists a square root, which is a natural number. Yes. Now for square root we use symbol like this. For example, if we want to find out the square root of 25, we will write like this and the answer will be 5. Yes. Now student, remember, if we take integer like -3, then its square will also be 9. And if we take 3, then its square will also be 9. Now if we write 9, then which answer should we take? 3 or -3, because both gives the same square. So here for class 8 we only take principal square root, that is the positive part. We will not deal with the negative part, that is one of the answer for every perfect square. Yes, so the principal square root will be talked even when it is not mentioned. Okay, now here are some square root and perfect square which you can go through and you can check how the unit digit of perfect square and square root are related to each other. Yes, okay, now we'll see how to find the square root of a number. Yes, because for smaller number it is easier to guess that what will be the square root, but for bigger number how we can do it? So there are different methods, and the first one is to find the square root of any perfect square number by repeated subtraction. So we have to subtract the numbers again and again. Student, there is a property of odd numbers, that is if we add consecutive odd numbers, then the number of odd numbers taken have the sum equals to the square of numbers that we have taken. For example, here we have taken 1, 3 and 5. There are 3 odd numbers, consecutive odd numbers. So its sum will be square of 3, that is 9. So this property is valid for any odd number but consecutive taken together, and if we find the sum, so we'll get the square of number of odd numbers taken. Yes, now using this property we can find out the square root of a number. How? Let's suppose if we had to find out the square root of 144 or 144. So what we can do it, we start subtracting the number starting from the first odd number, that is 1, and then we'll use the result and we will again subtract the next odd number, that is 3, and at the last stage you will reach 0, and the number of steps taken to reach 0 is the square root of the given number. Yes, so here we have taken 12 steps, so the square root of 144 is 12. So this is a good method, but it is quite easy to find out for smaller numbers, but for bigger numbers we have to see how we can do it. So to find the square root of a perfect square by prime factorization, student, we have already understood how to check a number is a perfect square or not using prime factorization. Now using the same concept or same method, you have to find out the square root of a given number, and for that what you will do is you will prime factorize the number and you will make pair like this. Yes, which we have already understood. If the number will be perfect square, then we'll see that all the prime factors will be paired. Now we can also write these as a form of exponent. Each pair can be represented in the form of exponent where the exponent is 2 always. Yes, now we'll take one number from each pair and we'll multiply them to get the square root. For example, here we have 2, 2, then 3, 3. So we'll multiply 2 times 2 times 3 times 3, which will give us 36. So square root of 1296 is 36. So this is a quite good method and it can be applied to larger number. Now student, there is another method which is square root of a perfect square using long division method. So for more larger number we can use this method. And what are the steps? What you have to do is you have to make pairs starting from the right side. Yes. So for example, we have 5 1 1 2 2 5 which is 5,11,225. Now we can make pair from right side like this, this and this. So sometimes a single number will be there which will not have a pair, but we have to mark it like this. And now what we'll do is we'll find, starting from the left, we'll find what is the perfect square which is nearest to that number. That is, for example, here it is 51. So we'll check what is the nearest perfect square smaller than 51 or equals to 51. So 49 is the nearest perfect square. So what we do is we'll write 7 over here, which is the square root of 49, and 7 also here. Yes. Now we'll write the value 49 over here and we subtract the number here and we'll take the next pair for the next step. Also we add these two, or we can say we just multiply this by 2, but basically we add these two. So if we add these two, it becomes 14 over here, and we have to check that what should be written with 14 over here, that should be written again in the second part. And if these two are multiplied, the product should be either 212 or smaller than 212. So if we check, it is 1 only which will give us smaller than 212. Otherwise, if we take any other number like 2, then the product will be greater than the required value 212. Now we follow the same process again. What we do is we again subtract these numbers and we again make the next pair here and we'll follow. Now we have 141, so we'll add the number that we have at here, so it will have 142. Now again we have to check what we have to write over here that should give us the number either this or smaller than this. So if we take 5, then the product will be equals to 7,125, and whatever number you take over here, you have to write over here also. Like for this we have 5, so we'll write 5 over here. Now if the remainder is 0, it means the number was a perfect square, and the quotient that we'll get, that is 715, will be the square root of the given number. So it is quite a long but easy method to find out the square root of bigger numbers. Yes. Now students, moving to the next question, that is example 12. What is the least number should be added to 1293 to make the sum a perfect square? So student, one of the cases where we have to multiply or divide, we have seen how to prime factorize and check what the number is going to be multiplied to make the unpaired factor as a pair. Now here we have to do the long division. In case of addition and subtraction, that what should be added or what should be subtracted, we have to do it using long division, where we find the square root using the same method that we have already discussed. But as we'll see a remainder over here, now in case of addition, if we have to add something, then we find out the next square of this number. Like we have 35, then we have to find the square of 36 and we have to subtract the original number 1293, because the number will be added to this to get this. So we have to check what is the difference between the required square number and the number that we have. So we'll get it. Now if we have to subtract from the original number, then we have to get the nearest but smaller perfect square. Like we have to take 34 if we have to subtract something. So if subtraction should be the case, then we will write 1293 minus square of 34 and we'll get the answer that what should be subtracted. And sometimes the question should ask what is the square root of that number. So we can check that 34 or 35 or 36, what will be the required value, will be the square root of the resulting number. Yes? Students, there is a shortcut method to find out the square root of a perfect square. So how we can do it? Let's suppose if we have a number 5, 6 to 5, we have to make two groups. One will be the ones and 10 digit group and other will be the rest of the digit, like this. Now, this group will help us to identify the unit digit of the square root using the unit digit of this number, that is 5. So 5 will help us to recognize that the square root will have the unit digit as 5. So we get our unit digit of the number. Now for the tens digit, we'll see that how much or which number is nearest to this 56 and a perfect square. Like it can be 7 square or 8 square, because 7 square is 49 and 8 square is 64. But we have to take the smaller one, that is nearest but just smaller. So for 56 it is 49. So it means the square root of this number will have 7 at its tens place. So we'll see that the square root of 5625 is 75. So in this method, what we do is we group the numbers in two ways. One group will be the unit digit and the tens digit, and other group will be the group of 3 or 4 or 2, how much the digit is left after grouping the first. Yes. Now student, the last topic, square root of numbers in decimal form. So for decimal numbers, we use the long division method that we have seen with some modification, like we have two part in case of decimal number. One is whole part and one is decimal part. So we have to make pair separately for decimal part and the whole part. And always remember the decimal part should always be present in pairs. Whole part can be a single digit which is not paired, but decimal part must be paired. So if there is a less digit, then use 0 to make the digit pair. Yes. Now how we do it? So let us take one example. Here we have to find out the square root of 6.4009. Now we pair it like this. Now we'll follow the same process, and whenever we have to take the pair after the decimal, we put a decimal over here and follow the same process that we have seen earlier. And if we need more zeros after that, we can put a 0 and we can have one pair, that is 2 zeros here. After that we can proceed with the same steps. Yes. Now if a non-perfect square is given, we can also use long division method to find out its square root, but in the form of decimal, because for non-perfect square number there is no square root that is an integer or a whole number rather than. Yes. So for a number which is a non-perfect square, then its square root will be in decimal, which can we find it out using long division method. So here we have 2. So in order to find out the square root of 2, we have to take a pair of zeros up to which we have to find out the decimal. Like if we have to find out 2 decimal, then 2 pairs are required, or like that. So you can do it. So what we have to do is we have to take a decimal and we have to make pair of zeros, and then we follow the same process that we have done for the decimal number, but the remainder will not come 0 anytime. So what we can do is, as per the requirement, 2 decimal or 3 decimal, up to 2 decimal or 3 decimal, we can keep that answer to that only, and we can write that the approx square root of that number is that. For example, here we have find it out the square root of 2, which is 1.41, but it is not an exact, it is approx, because there is not a fixed value for this. Yes. So student, I hope you have understood the concept of square and square root using this video. We'll meet in the next video. Till then, keep practicing, keep learning.